Okay, so I'm going to continue on with the multiple choice questions. And first of all, I've got the solutions here for this question here, which is just equating coefficients, question 50. You'll have something like that on the exam, but just remember when you're doing that, just to make sure that you expand this side out. So we've got, and then equate the coefficients. So here the coefficients of x squared was just a, so a had to be equal to 1. The coefficients of x was 2ab. We knew what a is, so we could find that b is equal to 2. And from there, the only option was to do was to select question part E. I wanted to do this one because I think they had a question sort of similar to this on your third SAC, and it was not done very well. First of all, in this question, it's saying that the time taken by the car is 1 hour more. We want to find an equation to solve for x. Well, speed is equal to distance over time. And we know that the time for the car is 1 hour more than the train. So I guess what we can then do is rearrange this rate formula to get time is equal to distance over speed. So we've got distance in kilometers, speed in kilometers per hour is then going to give us, these units are going to cancel out, this hour is going to go to the top, which is going to give us the time in hours. So how do we go ahead and solve this equation? Well, first of all, the time of the car is the distance it travels, both travel 100 kilometers, divided by the speed or the rate at which it's traveling. So it's traveling at x kilometers per hour. The time of the train is 100, same distance, divided by x plus 10 kilometers per hour. Now, in order to find an equation, we were given from the question that the car is 1 hour more time than it takes for the train. So we've got this over here, and it appears as though the answer is E. For some reason, we're sort of struggling with those questions. I'm not sort of sure why. I think it's just a matter of, we had to rush through the chapter to finish off the stuff for Unit 1, and we just simply, I sort of asked you guys to revise and do those questions at home, and yeah, without the practice, you're never really going to get it. So let's have a look at this. A simple ratio one, won't be too much of this on the exam. If we've got 6 in ratio to 7, 2 to x, well, we can treat that as a fraction. 6 divided by x is equal to, 7, sorry, is 2 divided by x. So therefore, we've got x is equal to 14 over 6, which if we divide the top by 2 and divide the bottom by 2, we're going to get 7 over 3. Let's go to question, skip a fair few. Okay, so let's have a look at this question. The length AB in centimeters is equal to. Now, look, you guys have done a lot with your basic triangles, but that's for right-angled triangles. When we don't have a right-angled triangle, we can't use SOHCAHTOA to find the properties of that triangle, say the lengths and angles and so on. So what we need to do is, if it's not a right-angled triangle, which this is not, we need to use either the sine rule or the cosine rule. So let's go ahead and look and see what they are. Okay, so for the sine rule, you can see here that the sine rule can be used when one side and 2 angles are given. So we can see that there. One side and 2 angles are given, or 2 sides and a non-included angle are given. So one side and 2 angles are given. Let's have a look. we've got one side and two angles. Now, so if we go ahead and try this, the cosine rule is only when two sides and an included angle are given. We're not given two sides, we're only given the one side. So it's apparent that from this rule that we can only use the sine rule. Now, if you go start using the cosine rule, you'll soon find that it won't work. So it's just a matter of first of all, knowing how to use those rules, and first of all, setting up the triangle how you're supposed to. So let's have a look at this triangle. We've got ABC. So we know it's the sine rule. What is the formula for the sine rule? Well, first of all, we need to set this up in that the lengths, this is actually the length, pen. This length here is actually A. So we've got angle A opposite to the length little a. This is going to be length B, and this is going to be length C. So obviously length C is opposite to angle C. What is the sine rule? Well, we've got A over sine A equals B over sine B equals C over sine C. Well, what are we trying to find? The length of AB. So we're trying to find what C is. That's little c. We're trying to find what little c is. And so in order to do that, though, we need to know what this angle is, which should be easy enough because big C, which is the angle, considering this is a triangle, big C is going to be 50 degrees, since all the angles in the triangle must add up to 180. So that's the first thing. But the thing is that if we're trying to find the length of AB, so we really can't use, well, we can use the angle C. So what we need to find is we're using C, and we certainly know that what little a is, and we know what big A is. So let's have a look and say, let's use, you don't have to use all of these here. You just need to use what, or look at what you're given in the question. So in this case, we know, or we're going to use the fact that we know what little a is, we know what the angle big A is. So we know what these two things are, so we can go ahead and use the sine rule. So let's do that. So little c, we've got little c on sine of big C is equal to little a on sine of A. Let's rearrange that now. So therefore, we're trying to find what little c is, which is the length of AB. So little c is equal to A sine of C over sine of A. What is sine of little a is equal to, well, that's not going to work, is it? We don't know what, we only know, oh, okay. So look, I've made a mistake there. We need to use what B is, don't we? So instead, that is going to be little b, and that's going to be sine B. So little b is equal to 12 sine C is equal to sine of 50, and sine of B is sine of 100. So the answer is 12 times sine of 50 over sine of 100, which is D. So I'm going to be making silly mistakes today, but anywho, it's what happens when you don't really prepare for these things. You just make them on the fly. Let's go ahead and do question number 80. Okay, so this is looking at arc lengths, and I guess if I was to just pause a second, show you the formulas which we're looking at. Okay, so in chapter 12, we sort of just skimmed over this stuff. You guys needed to sort of work on. There's not going to be too much on the exam due to that fact, but we are looking at the length of the minor arc is given by the formula. So if you think about it, 1 radian is the equivalent of 1 radius around a circle. So if we have a radius which we don't know yet, if we have a circle and we have a circle of radius 2 centimeters, then if we go around this circle, let's just use a different color there. If we go around this circle 2 centimeters, so let's just say there, then that is the equivalent, so this length around here is 2 centimeters. That's the equivalent of 1 radian. And it's really important that a lot of the time we're not looking at degrees in terms of circles, we're looking at radians because it's much more useful. So we've got 1 radian is 2 centimeters for this. So considering that we've got an arc length of 7 millimeters, and that is an angle of 18 degrees. We can use this fact that, well, the arc length, which is 7 millimeters, is equal to r, which is the radius, times theta. But this theta is in radians. So if we've got theta in radians, how do we convert? Considering that we've got 2 pi radians in a circle, then 18 degrees, how do we convert 18 degrees to radians? Well, first of all, there's how many degrees in a circle? There's 360 degrees in a circle. Now, if we were to have this 360 degrees, and we know that that equals 2 pi radians, then if we divide both sides by 2 pi, then we now have it 1 radian is equal to 180 over pi. So if we have 18 degrees, we actually need to go ahead and times that by, or sorry, divide that by 180 over pi to get our radians. So 18 divided by 180 pi is equal to 1 over we have to multiply it by, my bad. We have to multiply by pi on 180 to get to radians. So times that by pi. So we've got pi over 10 is this angle in here, 18 degrees. That's the equivalent of pi over 10. So now we go ahead and plug that into our formula. So our arc length, which is 7 millimeters, is our radius times pi over 10. So therefore we rearrange that. We know that the radius is 70 divided by pi. Which is going to be answer D. All right, so question 83. Area of a triangle. Well, whenever we're trying to find the area of a non-right angled triangle, so this isn't a right angle, this certainly isn't a right angle, then it's just a simple matter of using the area of a triangle formula, which is this. So half BC sine A. Okie dokie, so we've got, this is our sine of A. Sine of A is equal to sine of 30 degrees. Little b is 14. Little c is 12. And so therefore the area equals a half times 12 times 14 times the sine of 30 degrees. Let me work out without using my calculator. I've got a 2 by 2 by 2 triangle, which I then cut in half, which means that that's 30 degrees, that's 60 degrees, and that's our right angle triangle. So sine of 30, we're just looking at this triangle here now. Using our SOHCAHTOA, sine of 30 degrees is equal to the opposite, which is half of this 2 by 2 by 2 triangle is 1 over the hypotenuse, which is 2. So sine 30 is going to be equal to a half. So therefore we times that by a half. 12 times 14, well, 10 times 14 is 140, 140, 168. 168 divided by 4 is 27. Is it? So we've got 6 times 7 is 42. So the answer's 42. Pretty easy, that stuff, but we didn't get not much time practicing in class due to having to finish off the rest of our questions. Do another one here. Let's do the circular theorems one. POQ is the diameter of the circle, the size of the angle QRS. Well, first of all, I will draw a little line here because that would indicate that that's a chord. And let's have a look. That we know that if this is our equilateral triangle, because this length here is going to be the radius, this length is going to be the radius, those two angles are going to be the same. If those two angles are the same though, and this is a line, which we know there's 180 degrees in a line, first of all, this angle here is 110 degrees. So if that angle is 110 degrees, then we know that we've got two angles which are the same and they have to add up to give to 70 degrees. So we know that this is 35 degrees, that is 35 degrees. And what are we trying to find? We're trying to find QRS. Well, first of all, if we look at a chord, we could use the fact that there's one of the properties of the circle is that the angle at the center, if we have a chord, the angle to the center is 2 times this angle here. So this is going to be 2 times this angle over here, which is QRS. So we've got 110 degrees is this angle, which leaves the angle around here, if I was to redraw this angle around here is 360 minus the 110, which is 250 degrees. Now, using our circular theorem's property, which I'll just go and find. So using theorem 1, the angle at the center of the circle is twice the angle at the circumference subtended by the same arc. So we've got a chord, and we've got our chord, and the angle to the center is always twice that to an angle at to the circumference of the circle. So here we've got our angle to the circumference of the circle. We'll call this angle x, and we know that x is going to be a half of the angle over here, which is a half of 250. So the answer using that theorem there, and a lot of people struggle with these because you just need to practice them. I think they're lots of fun though. It actually tests out a lot of your problem solving skills, which some of us still probably need to work on. Question 88, I'm going to do another circular one and then stop for this revision multiple choice. Soon, in the diagram, PT is a tangent. If ORT is 35 degrees, so that's 35 degrees, the size of RPT. Well, we know that these are both the radius, and so that's an equilateral, or sorry, two sides of the triangle are going to be the same, so that's going to be the same angle, and therefore this angle here is going to be a 110 degrees. So we've filled out that, but I guess a lot of people sort of stop there and they don't really know, and it's sort of common sense that this is a triangle, and this triangle here, this big one over here, well, there's 180 degrees in that triangle, but one of the properties of the circle is that if we have a tangent to the circumference of the circle, then from the radius, that has to be 90 degrees. So this angle here has to be 90 degrees. We know that there's a line here, there's 180 degrees in a line, so therefore this is 70 degrees. So if we've got 90 plus 70 degrees in that triangle, which is 160, then this angle here has to be 20 degrees. So the answer is B. A number of students just need to practice more of those. It's not that bad, and do enough of those and you'll be okay. I'm going to do a few more multiple choice questions from your revision sheet. Okay, so I'm going to do a few more and then I'll finish it up for the multiple choice section. So the 70th term of this sequence, well, first of all, a number of you struggled to identify what sequence we're looking at because there's so much confusion with the equations. I think it's easy to identify what the starting point is. The starting point is at -8. Since these have if we look at each term, if we can actually add or subtract a number to get to the next term, then we know it's an arithmetic. If it's we have to multiply it by a common ratio r, then we know that that's geometric. Okay, so it's first of all, the really important thing first up is whether it's geometric or we have a D common difference, which means that it's an arithmetic. And then finally, whether we're looking at the sum, and I guess in this case, we're just looking for, we just need to look at the arithmetic sequence formula, which is t to the n is equal to a plus n minus 1 times d. So the 70th term in the sequence, well, therefore we know that n is equal to 70. We know that d is equal to, our common difference is we're adding 4 to each value, so d is equal to 4. So therefore t of 70 is equal to minus 8 plus 70 minus 1 times d, which is 4, which is equal to minus 8 plus 69 times 4. 70 times 4 is 280, so that's 276. 276 minus 8 is 268. Let's go ahead and pick out another question. What are we? Page 7, question 5. Let's do this one. Prizes in a competition are distributed in the ratio of 5:3:2. So whenever you're doing this, first of all, let's have a look at, there's how many parts in that? Well, there's 10 parts. I think that's the easiest way to do it. And then we've got $16,400 is divided into 10, which means that one part is equal to $1,640. The value of the second prize then is 3 parts. So 3 times 1640, 3 times 16 is 48, so that's 4,800. 3 times 40 is 120, so it's going to be 4,920. Fair to say I won't be putting too many marks on the exam over that, maybe a multiple choice question, hint hint. And I'm going to do one last one, question, let's do, let's pick out another one. Okay, let's do this one here, as my battery is about to run out. 1 plus a half plus a quarter. Well, first of all, we know that we're getting the previous term, and what are we multiplying it by? What do we multiply this by to get to that? What do we multiply this by to get to that? You need to know that because 1 times a half is equal to a half. Then a half times a half is equal to a quarter. A quarter times a half is equal to an eighth. So our an 8. 1 over 8. So our common ratio R is equal to a half, or 0.5. That's the first thing. Now, considering that this, what does this dot mean? Well, the dot means that we need to actually find the sum to infinity. Now, you can only find the sum to infinity when R is between 0 and 1. And it's less, well, and it's less than 1 as well, because it means that it's gradually getting smaller and smaller and smaller. So we can approximate a value to the sum of these. The sum of these is equal to A, which is our starting point, over 1 minus R. A starting point being 1, so it's equal to 1 over 1 minus R is equal to 1 minus half, which is equal to 1 over half is equal to 2. Should be easy marks, those ones, I would hope anyway. And look, I'm going to stop there. Got enough questions there for multiple choice. In the next video, I'll go through some short answers.